And any people here other than me watched Star Trek when they were growing up? So you all know who William Shatner is? Anyone knows that he went to space on Jeff Bezos' rocket and he published a book about it? So if it's okay, I'm just going to start with a really quote that really hit home for me when I read it. And he said this: I had thought that going into space would be the ultimate catharsis of that connection I had been looking for between all living beings. But when I went to space, I discovered the beauty isn't out there, it's down here with all of us. Leaving that behind made my connection to our tiny planet even more profound. It was among the strongest feelings of grief I've ever encountered. The contrast between the vicious coldness of space and the warm nurturing of Earth below filled me with overwhelming sadness. Every day we are confronted with the knowledge further destruction of Earth at our hands, the extinction of animal species, of flora and fauna, things that took 5 billion years to evolve, and sadly we will never see them again because of the interference of mankind. It filled me with dread. My trip to space was supposed to be a celebration. Instead, it felt like a funeral. And I read this, I was like, real science fiction out of space, and like that contrast. So I started with that. We have this belief from growing up. I had religious education, heaven is out there. Actually, it's not. It's down here on this planet. You go out of space, there's nothing. Coldness, voidness. And that's part of the context of why we're even doing this. And this world that can put that elephant out of the room, carbon emissions and tracking is politicized. There is a greater reason why actually we're doing this. Specific construction, I think most people, doesn't matter the numbers you look at, but construction is one of the world's largest industries, and because of that, also one of the largest contributors to emissions. And it doesn't matter how you counted it, there's no question that if you want to solve the issues of emissions, construction plays a part in that. And that's the context why we're now going one level deeper in construction. And you've got the sources there later on. Anyone sends me an email, I'll send them the presentation with all the sources. So the things we tried to cover today are basically 5 things. First, how do you start? You want to, after this presentation, you're going to go back after the jet lag and the hangover, and you'll say, okay, we want to start doing it, so I'll try to give you the tools what you can do with no one's help. You can do it on your own. Okay? We'll cover a bit. You will then have potentially in your organization the question why we're doing it. So let's cover a few things of the benefits. That's the second point. I'll try to share some examples from organizations that began the journey. Not too many, but for those who gave us access and share, I'll share that. And try to give some roadmap. What could you potentially consider doing in your organization this year? So, first about how to start. Now, how many of the folks here are working for a contractor as opposed to a dealer or manufacturer? Like, who's a contractor? Oh, that's so this side there must be the dealers and OEMs, yeah. Okay. So it's by the way relevant for both because from people who are dealers, manufacturers, there's still requirements from customers to provide that data for the equipment. Okay. So first level of understanding, again, if I'm saying things that are very obvious to a few of you, apologies, but let's very, very basic. Carbon emissions, first and foremost, are measured on the basis of the fuel consumption of the asset or the equipment. And my presentation today is focused on equipment. We're not going to cover plants for a second, other things. This is very relevant for that, but let's focus on equipment and on-road and off-road. If you have the data of fuel consumption, the ability to calculate from fuel consumption the carbon emissions is very basic mathematics. There are factors that are basically either set by the EPA or they can be derived for every single type of fuel type. And then the calculation is fairly simple algebra. 100 gallons times the factor equals your carbon emissions. And a very, very rudimentary level, okay? So a company that has 5 assets, the GC asks for get information. If you could know exactly the fuel consumption every day, then you know the factor, you can basically just provide that. Okay, thumbs up if this is all good. Yeah. Thumbs down is like, dude, we know all of this already. Okay, let's start with that level. Then there are some complexities, okay? Complexity-wise. If you're in California, for example, that factor will be different because you may have different fuel type. Even the diesel will be different from Arizona or Nevada. Even if you're in California, it's different depending on who supplies you the fuel. And some of these things are what Lewis Carroll in Alice in Wonderland called much of muchness, which is a British term to say whatever, okay? Meaning the gap will be plus minus 5%. No one really at the moment could care less if you report 100 metric ton or 102 metric ton. That difference is not, it's negligible, okay? That's much of a muchness. But you still want to know that. You want to know what you're talking about if you're reporting this data. There is a difference between fuel types of petrol, obviously, and diesel, and others. So, in terms of the KPIs that normally companies are expected to report back, the number one KPI will be carbon emissions as measured either in pounds or in metric tons. Okay, depends on the organization and the client. The factor between them, again, numbers. And if again, anyone, I'm not going to go super science on you, but if anyone later on wants to know, okay, where are these metrics, you can send me an email, I'll send them just the tables. Okay, these are factors, you just keep them. Okay, they do change over time because of how fuel is managed, but they're provided. And most people rely on the EPA data. You also want to know the other elements that then enter. Some companies, for example, go a level deeper. They report not just the carbon emissions, the CO2, but also NO, the nitrogen oxide, and other elements. And again, you can go deeper and deeper and deeper. But to a large extent, for those of you who are more in the expert side, is it fair to say, safe to say that CO2 is the number one metric that people would expect?
I have a question. Do local governments also ask for the particular matter at different sizes, like 2.1 and 10 and others?
Yeah, so I think to repeat the question, does local government also play a role in defining the metrics required to be reported?
I was wondering if the particulate matter also becomes part of what's expected to be reported, like by health agencies.
Yes. Yeah, so you really, again, if you're looking globally, and a few of the folks at CONEXPO come outside of the US, so definitely in other countries it will be very different, the expectation, the granular, and the accuracy. California, where I happen to reside, has its own requirements to the level. And as I'm sure most of you have noticed, this great country has within it 50 different countries, different regulations, different states. They each have somewhat different requirements as well. Now, that's also one side of the issue. And again, my goal is not to blow your mind out, but there is complexity here. Sometimes the people you're trying to report this to is not necessarily the government, it could be the customer. So if you're doing a project for Amazon or for Facebook or for Google, and they want to report on their ESG report the information about the carbon emissions of building a data center, then your customer will be the one actually mandating the level of information they need to provide. Okay? So it depends on the company and the work you do. So that's really the first point. The second point that you really need to understand, and I'm guessing everyone here is well close to the world of equipment, is understanding the machine types. There will be very different analysis of the carbon emissions depending on the machine you're talking about. So if right now I'm running a paving operation or earthwork operation, most of my assets are dozers, excavators, wheel loaders, that's one set of data, as opposed to industrial where I'm operating generators, pipes, other equipment that will have a different set of data, and we'll go into that in a minute. On-road, a few of the companies started using electric equipment, electrified equipment, that doesn't even consume, obviously, diesel fuel. Okay? So that'll be a different measure when we get to that. And I think that actually touches your question. There's complexity because of state regulations and energy sources. Now, one thing also to bear in mind, question that sometimes arises is, wait, how do we even measure it? Meaning, if right now I've got this truck and it consumes 100 gallons of this machine, do I just measure the carbon emissions involved in the 100 gallons that were burnt, or I need to include in that all the work that had to be done to even provide the fuel? Because lots of the criticism about electric cars is, yeah, right, they don't produce carbon emissions, but the amount of electricity consumed to get them to operate is significant. Usually the approach is you only report what you are in charge of producing, so you don't double count, okay? So in other words, if you're right now operating an electric wheel loader, and that electric wheel loader happens to have 0 emissions, you don't need to worry about the fact that in order to charge that electric wheel loader, tons of carbon emissions has been produced by the power plant and God knows what else, okay? So as you think about the emissions, you're involved in what you are in charge of producing. You don't start to do all the math of all the work that had to get to that stage.
Does that include the electricity you use if you're using electrical equipment?
Correct. That includes that, correct. Because otherwise you're going to be in the world of trying to calculate literally the amount of carbon emission involved in the guy who put gas in your tank in order to drive to the petrol station. It's a never-ending story. So for simplicity's sake, think about from an academic perspective, you are counting what you're in charge of basically producing, okay? And that also answers when you see lots of criticism around, oh, this doesn't make sense, we actually do produce. You want to hope that someone in the government is actually counting all the different stages along the path, but that's not something you and I need to worry about. Now, I mentioned earlier the factors. So this is literally a screenshot from the key factors, and you can see here at the bottom, diesel and home heating fuel, and that's a number that some of you have done it before, maybe already remember. What's the factor for every pound of, or every gallon actually, of fuel? You have a factor of how many pounds carbon emissions are generated. Okay? And again, not to go too much into chemistry, internal combustion engine consumes fuel. That fuel in its burn produces CO2, and that's basically what we're measuring here. Okay? How many pounds CO2 are produced by the burning of that fuel? Okay? And the website, again, I'll give you later the link to the website. Different states will have different measures, and some companies get more and more sophisticated and maintain their own factors, and so on and so on. Okay? But you have to start somewhere. The easiest way to start is analysis paralysis, and they're like, oh, we don't have the real number, therefore we're not going to start. You don't want to be in that camp. You can start with a camp of a very specific hard-coded factor of 1 gallon of diesel produces X amount of pounds of CO2, and that's it. Okay? It's literally not much more complicated than that in the first stage. Is that okay? So let me stop 1 second here because I think that was already. That's like, I'm trying to, that's the 101 level talk. So let's 1 second park it here. Any questions so far?
When you do those calculations, you use the OEM calculated fuel burn, or you use actual fuel burn for what's against the fuel?
Great. Is that okay? I'm going to repeat the question. So the question from Tim was, what do I use to know the fuel? Do I use what the OEM reports? What do you use? So the quick answer is you use the best number that you have access to, which really brings me to the next slide. Because if I ask you right now, how much fuel your car consumes, can you tell me that answer easily? The answer is no. We all have a fuel gauge tank, right? Full tank, water tank, so on. Who here knows what's the size of the tank of their vehicle? Put your hand up. Okay. What's the fuel? What's the size? 23 gallons. Okay. And 12. What are you driving? A Civic. Good. Now, interestingly, do you ever overfill? Like the fuel tank level ever goes above the? Never happened to you? It always goes a bit up, right? So even to know correctly the tank size is not that straightforward sometimes. Okay. Now, so going back, Tim, to your question, the most accurate data comes from some OEMs, so CAT, John Deere, Komatsu, and 20 others, will provide for you the fuel consumption. So that's a screenshot from JD Link, the John Deere telematics system, and as you can see, the fuel totals, actually the machine is reporting it. That's not an advertisement for JD Link. Every single OEM right now sells every, at least on the heavy side. Cranes may be different, but let's stick to the heavy. Is there anyone here in the audience that's never used Vision Link, JD Link, Comtrax, Volvo CareTrack, or one of these systems? Okay. Should I explain in short what they do?
I've done these calculations for transportation, so
Okay.
stock construction.
I'll give a 20-second explanation. Basically, that equipment exists on the computer in every truck, in every machine, and that information gets sent to the internet, to the cloud. And that information includes useful information like the total engine hours, and also the total fuel consumption from the second the machine started living, okay? And we take the cumulative engine time and cumulative fuel consumption, and we just say, okay, the machine today consumed 9.3 gallons. So Tim, that will be the most accurate. Why? Because that's what actually the machine produced. Some people have the wrong opinion that because the machine doesn't high load or low load, it produces more or less. Now, it's true that there are differences depending on the machine and filters and so on, but to a very large extent you can count on the fuel as the correct metric to measure the carbon emissions from, okay? Or put differently, 10 gallons spent on high load versus 10 gallons over 2 hours versus 10 gallons spent on low load over 5 hours will still roughly produce the same level of CO2 emissions, okay? And I don't know if there's a scientist here, that maybe I'm wrong, but am I wrong from those of you? No? Very good. Okay, so that's a bit of like a misnomer about low load, high load. Irrelevant. Focus on the fuel consumption, that's the metric from which you measure the carbon. Okay?
Are there when do these systems start in those vehicles? Are there model numbers where someone might not have access to that?
I would say to a large extent, in the last 8 years, every single heavy asset you acquired came with telematics. The last 3 years, on John Deere it's free, and Komatsu is free. Vision, you pay a bit of money, depends on the system. Some manufacturers give it for free. Okay, some do not. That's on the heavy. On-road, I have no idea how that happened, but on-road assets do not report fuel consumption. They report the momentarily fuel consumption, like in your car, you see, oh, I'm on 20 miles per gallon now, or 13. Small problem, they don't report easily the cumulative fuel. Put differently, you cannot get from your Ford F-150 easily that metric, unless Ford will literally provide it for you. So in those cases, you actually can rely on something else, which goes to the complexity. You might just need to know how many times you fill the tank. And when you fill the tank, how many gallons you put in. Okay? Which means your numbers will be a bit incorrect. Why? Because if you consumed 10 gallons on Monday, 10 on Tuesday, 10 on Wednesday, 10 on Thursday, and then you put 40 gallons on Thursday, you fill up the tank, your system will report as if you produced all these carbon emissions on Thursday. Right? Make sense? Now I know that this presentation is a bit hard because it's a bit not logical, so if I'm boring anyone, please do tell me. But I hope that point makes sense. So imagine right now your GC or your owner asks you, I need you to report to me daily emissions. If you don't have how much fuel it's used every day, and you're relying on when you filled it, then by definition there's going to be a bit of a time lag there. Okay, you're not truly reporting the true fuel consumption daily because you don't have that piece of data, right? Overall, it will even out after a month, after a week, right? Unless you don't fill the tank for like a month, which is rarely the case.
So question, once you have this data, so like your overall is 9.3 gallons for the day, right? Then you, per 100 gallons, you would multiply it by the X factor, so you just have to multiply this out.
Correct. So, for example, in this case, I will take 9.3 gallons. If it's diesel, I'll take the factor, which is, let's say, 22.45, and then I'll say, okay, I produced to this number times this, 9.3 times 22.45, whatever that equals, 180, that day. That machine produces that amount of carbon emissions that day.
Okay.
In pounds, yeah.
Sorry.
Yes?
So these are basically, this is the numbers based on if your engine is operating the way the manufacturer says, if all that is happening. So in theory, if your engine's running subpar, this calculation is not 100% accurate.
No, so I'll answer, no, that is not correct. I'll explain. Let's go again. I always feel I need to apologize because this is a bit complex, which is why most people don't bother doing it. But it's not that complex. Every machine on the engine actually measures the flow of fuel. So on the heavy equipment, 9.3 is the true amount of fuel that went through and consumed through the operation of that machine. It has nothing to do with how you operate at ideal conditions. It's literally the amount of fuel that went from the tank into the engine through the operation. Okay?
But doesn't the efficiency of how that engine is consuming and using that the output?
It measures it in doses through the injectors. It knows how long the injector was open, what the pressure was, that kind of thing, volume. It just has to help out.
But the efficiency is measured to the second degree, or sometimes the third. So the gallons and converting that to carbon dioxide is one calculation, but utilization
So from telematics, I hope I'm answering the question you asked. So first, the fuel itself is the true fuel the machine consumed.
Yeah.
You don't need to double guess that number. On top of that, there will be additional numbers, like what's the idling, okay? And I will not have a presentation now about idling and the complexity. What we actually call idling is not true idling. It's specific logic of whether the RPM was that, and the implement is implemented, depends by OEM. We can open a can of worms of idling. But when it comes to the fuel consumption, that will be the fuel consumed by the machine. Okay? I hope that was the question.
We'll
Okay.
get there.
No, but please do, because I may have, would you like to elaborate on the question?
No, for now, I'm good, thanks.
Okay. But in short, if you have, hey, can we trust the number that the OEM, John Deere, Komatsu, CAD, Doosan, Hyundai, give us on the fuel consumption? The answer is yes. That is what the machine uses. Okay?
I do think that the question the other person asked about OEMs, so it would depend if the OEM is using the correct emission factors for that year, and also the engine type and the way that also impacts
Correct.
fuel economy.
So bear in mind, none of the OEMs at the moment, I think Volvo is about to do it, but not yet, none of them report emissions. They report fuel consumption. Why do they not report emissions? Because how you calculate emissions? Emissions equal fuel times factor. They have no clue which fuel you put in, which diesel. They have no idea if you got diesel from California, from that vendor, or from Nebraska, okay? They, by definition, if they give you emissions, you have to smell it and say, probably they don't know what they're doing unless they have a system where I can input my factor, which at the moment none of these systems actually do, okay? And in fact, I will even tell you it's actually quite problematic. We as a company, we're a software company, we don't sell hardware, but we work with everyone. We work with Samsara and Geotab, and it's actually quite dangerous. I noticed a few of the OEMs did start producing emissions, but when we reverse calculate the numbers, we realized they have no idea what they're doing because they're using a single metric regardless where they are in the country, regardless of Canada or the US. It's literally hard coded into the system, and you don't want to do that. You want to use the fuel to calculate your own numbers, okay? Because that factor is basically the factor of the specific fuel type you're using. Okay. Yeah, Tim?
Just to clarify why I asked the question, we track our fuel purchase and burn, and we have a very good system. Our fuel variance when tracking our fuel is less than 2%, which is within the error margin I gave you. When we calculate that against what the OEM say we burn, we find about a anywhere from an 8 to 10% variance with the OEM said and what we actually burn. So we use fuel expense, we don't use OEM.
Right. And then you get, so to repeat the question, basically Tim's saying, listen, we measure the cumulative number of fuel here, we measure how much we actually put in the machine, and there's a gap of about 10%, correct? And I would absolutely, I would speak later. First, anyone else notice that problem in their data? A gap of 10% between, from our, we approach it very scientifically. What I mean scientifically, we'll literally look at the fuel reporting, if it's the fuel card or the WEX or some system, which OEM. And there's only two scenarios. There is a truth out there. There's physical amount of fuel that went in. It's not too complex actually when you isolate things to find out where is the discrepancy. More often than not, actually does come from the fueling. Okay? Usually it's, not to be too sarcastic, but the person charging you money is probably the one more likely to suspect that the numbers will be incorrect, okay? Although, one may play the devil advocate, will say, well, also maybe the OEMs are downplaying the numbers, but at the end of the day, you can really very quickly assess that. We have not seen that actually across, we have about 70,000 assets we're tracking in our company. I've not seen that level of 10%, okay? Which, also another point, 10% is still negligible. Why? Because most contractors have no idea. It's what we call null, they have no idea. So at least you have some idea, right? Later on you worry about the 10%. Okay? If my son, my 7-year-old, cleans the room 90%, I don't give him a grief about the 10%. I'm like, okay, you're okay. This was what I talk about fuel level. I love to bring up a Ford example. People think they know how much, what's the tank size of the Ford, but actually you cannot tell easily because the wheelbase determines it, and you cannot even know if you're on a fleet of 1,000 assets, you don't even know your wheelbase based on the VIN because it's not saved in Ford by the VIN. So you literally, why am I sharing that complexity? Because we have the company we worked with, and we had to measure for them carbon emissions of their Ford equipment, and we only have access to the tank level, sorry, to the fuel level, 24%. But if we don't know the tank size, and it's literally not even written in any way that you can access easily, it's a problem. Okay? Now you enter the world of a bit more discrepancies. There's a big difference between a tank size of 30 gallon and a tank size of 48 gallon. And it literally can vary by, take the F-150, by the trim, if it's a super crew or not, or which wheelbase it is, the 48, I forget the number, 48 inches, or one of you guys probably know better than me. So it varies, okay? And you cannot even go to Ford's own system or to your own system to know which wheelbase it is, because you cannot get that data from the VIN. Did anyone understood any of the words I said here? Yeah, fine. Those of you who did not, don't worry about it. What I'm trying to say is that now we're entering the darker world in which the data is not going to be as accurate. Okay? Now, another problem on the fuel level. Anyone here lives in a place that there are something called hills or mountains? Have you ever noticed that the fuel level changes? Because it's something called gravity. So fuel level fluctuates. What do I mean by that? Even if you picked up, and we have our system that pick up the fuel level, you cannot use it to know necessarily where you are, because it will fluctuate. So then you need to have another system in place to smooth these movements. Okay? So there are headaches there. As you go deeper into the data, again, how many people here are purely in IT, literally work in IT? One person, two people. So for you guys, I'll tell you, there's an even different problem. Sometimes these systems will just throw a number off the charts. All of a sudden, 120%. And then they go down again. There are at least 2 OEMs that have that problem. Then you need to know to clean that data. Okay? Now, this is why most companies here, I don't want you even to worry about this at all. I'm just trying to explain there's another way to measure carbon emissions through knowing the fuel level and where you are. Okay? But unless you have a very strong IT team, you probably do not want to work on that problem. You want to find an off-the-shelf product, or you want to have a big IT team solving that. Okay? Because there's too much headache and it's too fiddly. Tons of companies have old assets. That's all they have. Forget about telematics. It's a generator that has like an hour meter. Okay? So another way to measure carbon emissions is simply by knowing the average of how many gallons on average over a month per operating hour the asset consumes. Anyone operating drills here and pipes and things like that? No, no drills. Okay. Engines, just big engines. So on big engines, you can just read the hour meter, and you can measure on average per operating hour on, let's say, a mid-level load, how many gallons it consumes. And then by the end of the week and the month, you read again the hour meter, and you can guess, okay, we had 120 hours. 120 hours, we assume on average, let's say 6 gallons per hour, so that's 720 gallons. You use the factor, and you come with the carbon emission. Okay? So we started from something very accurate, how much fuel consumption. We then moved to how much fuel I've got in the tank, which I said will be complex, but you can calculate it through that. Now we're into the world of, I've got some other numbers. I've got engine hours, that's all I've got. I don't have fuel consumption, I've got engine hours, so I can use that data as well. From engine hours, I'm getting how much fuel, and from the fuel, I'm getting how much emissions. Okay, do you get the tricks we're doing here? Okay? The complexity is knowing the math here. The complexity is all very picking up all these pieces. Now, one second before we go ahead, let's stop questions, and then I'll go to the next section. Any questions so far?
Do you know of any aftermarket telematics that will measure fuel actual use through prior to the
Yes, there are a couple of hardware manufacturers. I think at least one of them is at the show, OEM Data Services, OEMDD, or again, ping me later, I'll give you direct the contact in the CEOs of the folks in these companies. Challenge is very useful when you have expensive equipment. Let's say you're in oil or industrial and it just consumes, so you're going to install it. You're going to go through the hassle of putting a sensor to measure it. Other cases, you've got 500 assets, you're not going to install a tracker on every single one of them. It doesn't make any sense, okay? So if you do need that, there are solutions for that, yes. Yeah, that's a great question. Now,
Does anyone use vehicle miles traveled either? Through the
yes,
odometer?
and I'm going to get to that. That's the easiest. The question was, did anyone just use odometer? Of course, with mileage per gallon. And we're going to get back to that. Now, at this point, I want to stop 1 second and say, okay, why the hell are we doing all of this? Because I did start with the William Shatner slide, okay, and we'll, I hope a few of you felt fuzzy in the heart, but there's also other reasons why to do it, okay? Reason number one is just very clearly, once you have the numbers, it's fuel savings. Anyone here does any sport that they measure themselves, running, swimming, something? Take running as an example. There's never been any person that was able to run faster if they didn't have a stopwatch. Like, it's just impossible. You cannot get better in anything you don't measure. I'm still trying to find an example where something you can get, well, I'm sure there are things in life you can get better without measurement. Mainly the negative things. But the positive things is very hard. So, if you want to improve fuel savings, by definition, your ability to measure it and know where you are will help you tremendously. You're debating in the show whether to buy a Volvo or a Komatsu, a Caterpillar, a John Deere. If you knew the maintenance cost, the fuel cost per hour, you started to measure it, you'd be better informed to make these decisions, okay? So just a pure measurement, I hope that's for granted. It pays off in dividend on having the data. Second one is depreciation, completely related to that, residual value of the equipment, depreciation, replacement of parts, and maintenance. Sustainability, both from the side of hitting targets and also from hitting every single bid that you would want to win in the future, whether it's a local government or federal government, health reasons, needless to say. Okay, so there are many, many reasons why once companies do emissions tracking, think of it as the new safety. Safety wasn't what it is now 50 years ago, but now no one questions like safety. You'd be hard pressed to find a company that safety is not one of their tenets. Okay, emission tracking is still going to be one of these things. Maybe we're 10 years out from that. Maybe we're 5. It's just a question of time. And this is a bit deeper, I'm not going to go too deep into that. On the business growth, again, I don't know how much in the US, I think I'm told that from a federal perspective, sooner or later, or maybe it's happening now with some, you literally will not be able to bid for some jobs if you don't have the data. So that's very easy. You want to win the job, you better give it, right? You want to try to tell the government you give it and give them incorrect data, good luck. Probably won't see you next CONEXPO. Can't visit you. But the other reason is also business. Yeah, business means the customer. Depends who the customer is. If you work with any company that ESG is in their shareholder report, you have a better chances of winning that bid against someone else that doesn't give you. Imagine you put in the bid, and anyone here is in BD, or no one here is? Anyone is working business development? So in the BD, if you bid, you just imagine your bid versus someone else, all things being equal, but you also tell me you have a system to measure the emissions in real time and report them daily. Anyone wants to guess who's going to win? So there is a BD element, pure and cold business reason to do it. So how much time do we have? Okay, we've got a few. So I'm going to just try to give a few examples of companies doing it, and then open it up for more questions. So, companies worth speaking with. Los Angeles County Sanitation Districts, Dave Bolderoff is the equipment director. And again, I've got cards there, send me an email. If you don't know these guys, I'll make an introduction. Dave has tons of information because they're part of the government. They're using lots of electric equipment now, more and more. And they generated very interesting data about savings and maintenance, obviously tracking emissions through what they're doing now. Okay? And they still didn't compile them, so didn't feel comfortable giving me like a proper official numbers, but one-on-one, if you want the introduction, there will be ones that I definitely start with. Okay? Anyone spoke with Dave already, or no Dave? Yeah, Tim, was it useful to?
We call him Mr. Sustainability.
Mr. Sustainability, they call it. Good, there's a reason for that. I want to share with you something from the UK. Is anyone here not from US and Canada? Okay, here? Which country? New Zealand. So you're probably going to be the only one to understand the accent in this video. I'm kidding, it's not that bad. Let's see. Does it work? The usual problem of sound not working.
The idling time and to look at at the fuel, the idling time.
Second, go back a bit.
Environmental and Sustainability Advisor for M3, which
Oh.
is water and wastewater. So machine maps we are using for to monitor the idling time and to look at the fuel consumption, because as a company we are trying to reduce our carbon emissions and things like that. Having data, like having a monitoring system in place, it actually helps so that we can create that awareness around that. With machine maps, we were in the past, when I was working on Aegis to Houston, we were able to reduce 10% of our carbon emission, which is good when we're working in utilities, because it's really hard to turn that engine off and on, again. And I think getting that data in place was really useful to see the performance on some of our plants, and if we needed to change any plant, we did bring some like hybrid and electric plant, just because of the data that we were getting from machine maps. Before, we didn't have a report or system in place to monitor, and it was really challenging because we were just doing an estimate, and now like using telematics, you can get the accurate, and you can actually see the real time. For example, if someone is actually using the plant, you can actually see the person is using that plant, and he has used that plant for so many hours. So that we didn't have that data before, and now we have it, and we can work on that to reduce the carbon and be more sustainable where we can.
Okay. So that's a company I can send again everyone. The case study numbers, that's from Murphy, one of the largest UK contractors. Let's make one example of a company we work with, Michaels Corp, Wisconsin Industrials.
Did you work with Machine Max on that?
Say again?
Did you work with Machine Max on that?
No, we did not. Machine Max is another company in the space. They're not currently owned by Shell. Good, here we go. So we have someone from Machine Max to ask a question here. Fantastic. Do you want to add anything to the video and the experience?
Just, the Machine Max is really just telematics for if your machine doesn't have telematics, and software to go with it.
Great. So machine that doesn't have the OEM, you can put the tracker on, correct?
Yeah, and it's got software that works with compiling multiple OEMs together.
Beautiful. So that's for the context of, again, how to measure, because it all goes back to the most accurate way of measuring the data. And I want to talk about example, okay, how does all of this look in action? Because you're going to leave here and say, okay, how can I do it myself? So I want to share with you in 2 minutes, how does it look like when you start to do it yourself? This was a project we ran for TC Energy in Texas. And I literally took a screenshot of the Excel, how it looks like. So everyone here, when they have a job, will have, by the way, I send you the presentation later, so you can take screenshots, but I'll send you, have a much better resolution. You have the equipment data, okay? Each one of the equipment, you actually created a separate model. We call it emissions model, okay? You had a question about mileage. So mileage is the easiest one. You have no data about fuel, but you know the mileage. For mileage, you can use an assumption about miles per gallon, and therefore mileage gives you gallon, and gallon gives you emissions. Is it super accurate? No. Is it better than nothing? Absolutely, okay? Levels of risk, levels of estimate. So for example, you see the F-250s, you see we know it's the F-250 cruise super crew 160 wheelbase inch, and therefore the tank capacity is 34. Okay? And then from that, we also use an assumption of the fuel average MPG, miles per gallon, and from that we'll use the emissions. So we literally built that model for every single asset. It's quite painstaking and painful, but it's doable. There's a Silverado, and so on. You see also the fuel type is gasoline. They actually only do gasoline and diesel. They don't differentiate between diesel of different sources, okay? You can even make that even more complicated. The water truck is also mileage. The pipe cradle just doesn't produce emissions, so it's a zero emission model, basically it's zero. Then you've got the fuel tank level on the other F-250s. So some of the F-250s, we did have the fuel tank level. So we can take the fuel tank level, and we know if the truck started the day at 53%, ended the day at 40%, let's make it easy. 50 went down to 20, okay? So that's 30% of the fuel was used. If we know the tank size is 50 gallon, 30% times 50 gallon equals how much? 15. So we know it consumed 15 gallons that day, and we can come up with the emissions. Okay? So it's very fiddly. Not rocket science. Your second grader's kid could do that math, but it's fiddly. Okay? Mileage, same now. Then on the truck, we on the trucks actually had we did have tank fuel level on the last F-250. So we knew actually the fuel level. And for that one, we have a different measure. And then we have, for the welder at the end, we have operating hours. Another one, we had actually an excavator, we had the operating hours. So you basically end up constructing different models depending on the source of the data. I did not even talk about the easiest thing for you guys all to do, which is just take the fuel dollars. And most companies just say, okay, we spent $5 million on fuel, average fuel price is $3, therefore we bought this amount of gallons, and therefore we did this amount of carbon emissions. That's okay. If you have nothing else, it's better than nothing. Is it accurate? Of course not, because you're completely mixing in every single thing. And that's assuming everything is diesel, not petrol, and you know the weighted average, but it's better than nothing. If you are using a fuel card system that identifies what fuel went to what equipment, it gets better, okay?